So your duty after that is that you have to revise the notes. Okay, revision. Okay, revision. Revise means revision the notes. Once again, you have to go through the notes. Okay, and you have to just check how much you knew. Okay, try to just do the derivation by yourself once at least. Okay,
Yes, sir.
so now what should we do? Should I start from the gravitation after this, or what should I do? Because uh, and let me tell you, rotational motion is one of the most difficult uh, unit or topic you can say in the whole 11th class. Rotational motion is one of the most difficult or complex topic. Okay, so to understand the rotational motion, the concept, the previous physics you have physics, the previous physics you have learned, you should know. At least I will say you must know for the rotational motion. I am saying gravitation is a easy chapter, and that properties of matter is very easy, not that hard. Rotational motion I can say is little bit tough for 11th student. Okay, so what we should do now? Should I start the gravitation after this, or in the same way should we move after that? This way I should start the uh, work, power, energy, and after that gravitation. What you want, both of you?
So,
Hmm?
so we
Hmm? Okay, no problem. So basically, we will discuss this thing na, after the class. Okay.
yes, sir.
Hmm. Okay, Divyangi. Okay, should I start now? Divyangi and Hiba.
Yes, sir. Yes, sir.
Okay. So, Hiba, do you know Hindi?
Yes, sir. I mean, yeah.
And Divyangi, you also?
Yes, sir.
Okay, fine. So basically, centripetal force. In the last class, I have discussed, and okay, so centripetal force is basically a force when a body is moving in a circle, and this force is required by the body. Okay, and centripetal force to the body is provided by some external force, and that can be the tension, gravitation, electrostatics, and friction force. And basically, the centripetal force is net force toward the center is centripetal force. Okay, this concept in numerical will help you. And centripetal force formula is mv square by r and mr omega square. So today we will see some of the application of the centripetal force. Okay, so we will see some of the application of the centripetal force. So before that, I want to tell you what is the frequency and time period. Okay, what is the frequency and the time period? So frequency means uh, suppose this is a particle, and this particle is moving on the circular path in anti-clockwise direction. Okay, this particle is moving on a circular path in anti-clockwise direction. Okay. So frequency is basically number of revolution made by this particle in 1 second. Number of revolution. Suppose this particle made 2 revolution in 1 second, then frequency will be 2. Suppose this particle made 3 revolution in 1 second, so frequency will be 3. Okay. So frequency is basically the number of revolution made by the particle in 1 second. So unit of frequency is 1/second. Okay, basically frequency is number of revolution divided by time or second. So it will be 1/second. The unit is 1/second, or this 1/second is also known as hertz. Okay. And there is a relation between the angular velocity and the frequency. Angular velocity is equal to 2 pi times of the frequency. Angular velocity is 2 pi times of the frequency. Okay. And after that, time period. So time period in a circular motion, time taken by the particle to complete one circle. Suppose the particle started the motion from this point and the particle is moving like this, like this, like this, and finally the particle is at A. Finally the particle is at A. So in this motion and during this journey, the time taken by the particle is the time period. So time period is time taken to complete one rotation or revolution, you can say. And this time period is given by 2 pi by omega. Time period is given by 2 pi divided by omega. Okay. And there is a relation between the frequency and the time period. Okay. There is a relation between the frequency and time period. So frequency is 1/time period. Okay. So this relation you should know. Okay. Frequency is 1/time period, and time period is 2 pi by omega. Okay. And frequency is 1/time period. Okay. So now focus on this question. This is very good question, I will say. This is the question given. Basically, this is the string, and a mass is attached from this string, and this mass is rotating in a circular path like this. Okay, and this string is making an angle theta with the vertical. Okay, so basically what is happening, you have to imagine, suppose this is the vertical. Suppose this is the vertical, and from this vertical, this is the vertical, and here is mass. At the end of this pen, you can imagine, okay, imagine this red color is a mass, and this red color mass is rotating like this. Okay, rotating like this. Okay, rotating like this, like this. Okay. So this mass is rotating like this. Basically, you can say this mass is rotating in a circular path, in a circular path, and we have to find the time period and the frequency of the revolution of the mass. Time period and the frequency of the revolution of the mass. Okay. So how we will find the time period and the frequency, time period and the frequency of the revolution of this mass. Okay. So this is the question. Now focus on the mass. What the mass is doing? Focus on the mass. So this mass is rotating in a circular path. This is the circular path in which this mass is rotating. Basically, this mass is performing the horizontal circular motion because this mass is rotating in a horizontal plane. In a horizontal plane. Okay. So suppose I am supposing this distance is r. Okay. So the mass is rotating in a circle of radius r. Suppose this is not given in the question. In question, only theta and L is given and mass is given. So this I have supposed r is the radius of the circle in which this mass is rotating. Okay. So now as this mass is rotating in a circular path, so there will be a requirement of the centripetal force, obviously. and that centripetal force, for providing that centripetal force to this mass, there should be another force. There should be another force. And which force is there? Here is the tension force. So tension force is there like this. This is the string. When this mass will rotate, so there will be tension in the string. Okay, there will be tension in the string. Now this tension is in this direction. This tension is in this direction. What we will do, okay, suppose I have drawn a line parallel to this vertical. This is the vertical line. To this vertical line, I have drawn a line parallel to this vertical. This angle is theta. This line and this line parallel, and this is the length of the string, or this is the string. So you can consider this as a line. So if this angle is theta, so this angle will also be theta. Okay. So this angle will also be theta. So in this direction, Divyangi, what will be the component of the tension in this direction?
T cos theta.
Yeah, right. T cos theta. And another component of this tension will be in this direction. That is T sin theta. Okay. So one component is in this direction, another component is in this direction, means towards the center. Okay. And this mass is rotating like this. So there will be the force of gravitation or weight of the mass in the downward direction. In the downward direction, there will be the weight also, mg, m into g. That will be the another force on this mass. Okay. So in this direction, this is the force T sin theta. This is T sin theta. And R is the radius. Okay. So you can draw the radius like this also. This is the radius R. And this also with the radius. Okay. Now on the mass, this mass is rotating in a circular path. Okay. This mass is rotating on a circular path. So for circular path, there should be the centripetal force. There should be the centripetal force. And what is the centripetal force? Net force towards the center. What is the net force towards the center? T sin theta. And what will be the centripetal force? If I say that in terms of omega, I want to write the centripetal force. So I can write m r omega square is equal to T sin theta. This is your equation number 1. Now this mass is moving like this. This mass is not moving like this. So you can say there is no motion in vertical direction. So in this direction there is no motion. So this force must be equal to this force. So T cos theta is equal to mg. T cos theta is equal to mg. So you can write mg is equal to T cos theta. This is equation number 2. Okay, now divide the equation 1 by equation number 2. Divide the equation 1 by equation number 2. So this is T sin theta. And here is T cos theta. And here will be mr omega square divided by mg. This m and m will be cancelled out, and this t and t will be cancelled out. Sin theta by cos theta is tan theta. Okay, so you can write it as sin theta by cos theta only. Why? I will tell you. Sin theta by cos theta, this is r into omega square and divided by g. Basically, first we will find omega, and from omega, with the help of this formula, omega is equal to 2 pi by t, we can find the time period. Okay, so we will find first what will be the angular velocity of this mass. Okay, now this r is not given in the question. Okay, we have given that theta, L and M. We have to find the answer in terms of theta, L and M. Now see this triangle. Suppose this is O, this point is O, and this is A, and this is B. Okay, this point is B basically. Now see triangle OAB, triangle OAB. So this is O, this is A, this is B. Triangle OAB, and this angle is 90 degree. Okay, so this angle is 90 degree, and this angle is theta. This angle is theta, and what is this? This is R, and this is length of the string. So from here you can find the value of R in terms of length. Okay. So just tell me what is sine theta here. Sine theta here. Can anyone tell me from this triangle what will be the value of sine theta?
R by L.
Right. R by L. Why R by L? Why not OA by L? Okay, I am telling why. Because this is theta, and opposite to theta there is perpendicular of the triangle. Opposite to the theta there is perpendicular to the triangle, and opposite to 90-degree angle there is the hypotenuse of the triangle. So basically sine of theta in a triangle is perpendicular divided by hypotenuse. So perpendicular is R and hypotenuse is L. So basically R is equal to L sine theta. So now see what is the value of the R. R is equal to L sine theta. So put the value of R here. Put the value of R here. So this is sine theta divided by cos theta. And what is R? R is L sine theta. And omega square divided by G. So now sine theta cancel out with the sine theta. So omega you will get from here. Okay. So you will get here it will be G by cos theta. So omega square is equal to G divided by L cos theta. G divided by L cos theta. Now omega square, from the omega square you can find omega. Omega will be root of G divided by L cos theta. G divided by L cos theta. Now we have to find the time period and the frequency. We have to find the time period and the frequency. So there is a relation between the time period and the omega. So time period is equal to 2 pi divided by omega. So time period you can write 2 pi under root of L cos theta divided by G. Okay, so this is the time period. Now frequency is 1 upon time period. At the instant you have to think. At the instant. Okay, what is frequency? Frequency is 1 upon time period. What is time period? Time period is equal to 2 pi by omega. So 1 upon time period. So 1 upon time period means the reciprocal of this. Okay. So reciprocal of this will be 1 upon 2 pi, and reciprocal of this G divided by L cos theta. G divided by L cos theta. So basically time period and frequency. This is the time period and this is the frequency. Okay, so Hiba, can you tell me which force here is providing the centripetal force for the circular motion of this mass M?
T sin theta.
Yeah, yeah, T sin theta. Okay, T sin theta is the force that is providing the centripetal force to this mass M for the motion in the circular path. Okay, there is another question. This is the question. This is very good question basically. First read the question by yourself, both of you. Okay. Now we have to find the safest speed for which a biker to move on a circular path in a cylindrical well. So basically this is a cylindrical well and here is one biker and that biker is moving like this in a cylindrical well. Okay, riding the bike in the well. Okay, and you will say that this is very the size of the biker is very less. So in physics now we always take the point size. Okay, for bus also we will take a point, we will consider a point. Okay, so basically suppose this is the biker and this biker is moving in a circular path like this, and what will be the safe value of the velocity or speed, okay, for which the biker should not slip in downward direction. Okay, this is the surface of the well. Okay, suppose the biker is here, so due to the weight of this biker, okay, so weight will be acted in downward direction, so this biker has the tendency to move in downward direction. Okay, and mu is given, coefficient of friction between the surface of the well and the tires of the bike is given. Okay, so see how I will solve this question. So radius of the well is given. Okay, so first just focus or observe this biker. Here is a biker with a bike and this is a point we have taken. Why? Because in physics we take the point mass. Okay, for analyzing the motion we take the point mass. So basically this is a bike or biker. So basically this biker is moving on the surface, or you can say on the curved surface of the well in a circular path. Okay, in a circular path this biker is moving. So we will see the biker, we will observe the biker, and after that we will try to think which forces are acting on the biker. So first force I can say is the weight acting in the downward direction. Weight of the bike or biker, bike with biker is acting in the downward direction, mg. Okay, and another force you can see here, this is just the surface. Okay, this is the surface of the well suppose, and here will be the Viker like this. Okay, so this is a zoom in view. So there will be the normal reaction. There will be the normal reaction by the surface on the Viker. Okay, so there will be the normal reaction. So there will be the normal reaction. So this is the Viker, suppose with bike. So on this there will be a normal reaction due to the Viker is in contact with the surface of this bell. So what happens when something is in contact with some other surface? Some surface is contact with some other surface. That surface provide the normal reaction. Okay. So basically normal reaction will be there on this Viker towards the center of the circle. Okay. In which the Viker is moving. So in this direction there will be a normal reaction. Normal reaction will be there. Okay. Hiba, can any other force will be there? Coefficient of friction is given. Can any other force will be there on the Viker? Or you can say on the tire of the Viker?
Friction.
Yeah. And what will be the direction of that friction force? Okay, just wait. In this direction? Sorry. In this direction. Okay, this is east. This is west. This is north. And this is south direction. And this is the Viker. This point is the Viker. So, sorry. This is east basically. This is west. This is north. And this is south. And this is the Viker. So, in which direction the friction force will be there on the Viker? Or in between the tire of the bike and the surface? In
The opposite
which
direction.
Hmm?
The opposite direction.
Opposite direction of normal reaction or weight? You have to think here. Of. Okay, so Dibyangi, you tell.
North.
Okay, north. North means this direction, na?
Of weight.
Opposite to weight, na? Okay, right answer. Why? Because na this mass, now you can call it mass. So this mass or this biker with bike have the tendency to fall down or to move in a downward direction. Okay, just try to imagine what I am saying. So basically from this surface there is a tendency of skidding in downward direction. So basically this mass has the tendency of motion in downward direction. So friction force will be there in between the surface of this mass and the surface of this well will be there, that will oppose the downward motion of this mass. Okay, so here will be the friction force. Okay, here will be the friction force. Now for the biker not to skid, this friction force must be either greater than mg or equal to mg. Okay, this friction force, or we can say maximum value of the friction force, either greater than mg or equal to mg. Okay, and what is the maximum value of the friction force? Coefficient of friction into normal reaction. Okay, maximum limiting friction. This is basically the maximum limiting friction. Okay, maximum limiting friction. Must be greater than or is it equal to mg? So now put this. Basically, this is our equation number one. This is our equation number one. Okay. Now, as this mass or this rider with bike is moving in a circular path, so for the motion of the circular path, this mass required the centripetal force. This mass required the centripetal force, and what will be that centripetal force? That centripetal force will be the net force toward the center. What is the net force toward the center? This normal reaction. So net force toward the center is normal reaction. Okay. So I am supposing this mass is moving with a speed of v. Okay. So centripetal force you can write mv square by r. So r is the radius in which the mass is moving, and this is equal to the normal reaction n. This is equation number second. Basically, this speed we have to find. This speed we have to find. Now, equation 1 and equation 2 we have. Now, from equation 1, maximum friction force is greater than or equal to mg. What is the value of the maximum friction force? Mu into n, greater than or equal to mg. Now put the value of the normal reaction. Normal reaction is mv square by r. So it will become mu into mv square by r. This is greater than or equal to mg. So mass and mass will be cancelled out. So from here we can calculate v square must be greater than or equal to rg divided by mu. So the value of the v will be greater than or equal to under root of gr divided by mu. So the now you can see here the speed of the biker or the speed of the bike must be either greater than this value, or equal to this value. So we can say the maximum value of the speed. Okay, the not the maximum. What is asked here? The safest or the minimum value of the speed. The minimum value of the speed. Minimum. The minimum value of the speed is equal to gr by mu. For that, this mass will not skid or slip in downward direction. Okay, this will be the minimum value, gr divided by mu. If the speed is less than this factor, then no circular motion will possible. Okay, and the bike will fall down in downward direction like this, in this direction. Okay, and greater than this speed will be okay. Okay. Okay, so note down. Okay. Completed, Hiba?
Yes, sir.
Okay, so after this now, what I will do, mm, okay, I have to think. Okay. So both of you have completed the work power energy in your school. Completed now.
Yes, sir.
So we can start rotational motion if you want, but you should know what is energy conservation and how to apply the energy conservation. Okay, so that energy conservation will be required. Okay, and what is work and what is power, these things you should know. Then only I can start the rotation motion. Okay, so at one time we can start only one chapter now. So all the chapter we cannot cover in a single time. Okay. So Divyangi and Hiva, what do you say? Should I start from the rotational motion on the next class?
Yes, sir.
And Hiba,
Yes, sir.
but what you have to do now? Please revise before that the work power energy. Okay. So the concept of the work power energy will be used there. Suppose if I am asking what is work and you don't know what is work, then it will be difficult for me also. I will tell you at the time, but you should just revise your work power energy. Okay. So from the next class, we will start the rotational motion according to your syllabus. I am going. Okay. So actually, we have only 3 hours in 1 week. So, so I will try my best as much as I can complete. Okay. So, what is the thing now? For the final examination, okay, what you have to do? Just you have to do the revision in a proper manner. Okay, you have to do the revision in a proper manner means not like this. Suppose you have these notes. Okay, suppose I am the student. I have these notes. And what I will do, I will just see like this is radius and this is Viker and this is this figure and this is this is in this way you cannot learn the physics. You have to write, you have to do the derivation. You don't know how much time I have done this derivation. I cannot tell you how much time I have done this, only this that question and this derivation, then I am solving this today. Any concept you can take, how much time I have solved in one time. I have not just I am not a very, you can say, very some extraordinary person and all that. Okay, I have done a practice. Okay, because I am having an interest in physics, so I have done these derivation and all the teachers too. Okay, can do the questions very easily because they have done a lot of practice. And practice in the sense, I want to say that practice on pen and paper, you should do the practice. Okay. And if you have that any other thing like tab and all that, you can do practice on that, but at least you have to write. Okay. So if suppose if you are going to your home and you are watching your notes, if you are seeing your notes and you are just saying this is t sine theta and this is t cos theta and this is m, this is mg, and I will divide this. Definitely in examination, 100% you will not able to solve the question. For solving the question in the examination, what you have to do, you have to see only this part of the question. Only this part of the question you have to see first. Okay. And just see what is given in the question. Just see what is given in the question, and after that, see what you have to find. And after that, try to solve the question by yourself. For example, this mass mg will be there. Here will be the t sine theta and t cos theta accordingly. So in this way, you have to do the practice. Okay. For the further chapter or for any other chapter, for chemistry, for physics, for math, if you have. Okay. So this is the way to study. So when you will just see the question only and you will try to solve the question by yourself, then you know how much you know. Okay. Then you came to know how much you know about the question and what are your doubts. Okay. If you are doing some derivation, so don't see in the copy first. Do the derivation by yourself first. If you are just not getting, then see in the copy, then see in your notes. Okay. Okay, fine. So we will meet in the next class with a new chapter, rotational motion. But what you have to do, you have to revise the work power energy, because I know that without the work power energy, the concept of work power energy, that chapter will not be completed in a proper manner. So, okay. Okay, Dibyangi and Hiba. So we will meet in the next class.
Thank you, sir.